So it has been just over 6 months since I installed iTechWorld's 120X lithium battery under bonnet in my Landcruiser 200 series. Despite the concerns, warnings and doubting Facebook forums stating that it just wouldn't work, it would overheat, it'd shut down, explode or just deteriorate very quickly, the battery is still performing. But just how has it performed and has it retained its full capacity? In today's video, we're going to be doing a comprehensive 6-month review of this unit. We're going to be talking a little bit about how I've used and stored the battery and test this unit. We're going to be testing the peak discharge rates along with the capacity and comparing this to when the battery was new 6 months ago. We're going to be talking about the physical condition of the unit and some of the pros and cons that I've come across while using this lithium under bonnet. Let's check it out. If you missed my last video on this lithium battery, check it out up here. In that video, I went into detail about the differences between this lithium unit and my previous Full River AGM battery. I went on about how I installed it into the Landcruiser 200 series, how I changed the Red Arc BC-DC charging profile, and what measures I took to prevent heat damage. So it's time to get the battery back out of the cruiser and onto the bench. Firstly, my overall impressions, and this unit has really stepped up the power management in my Landcruiser 200 series in both the capacity and the peak discharge rates. Being able to draw from a 96 amp hour capacity when compared with my old AGM, which is about 70 amp hours, has resulted in longer standby times when we're sitting around camp and means I don't have to worry about starting the vehicle or plugging in some solar to get some charge. This has meant that not only can I sit around camp for longer, but I can also power more accessories with confidence. I have fairly standard electrical accessories in my setup, like a fridge and lighting. However, I also use significant power on accessories like my drone batteries, cameras, power stations, and sometimes the occasional freezer. So overall, this battery has performed much better than its replaced AGM counterpart and hasn't let me down yet. I haven't had any issues with any overheating, shutting down, or charging issues, and so far, fairly happy with the performance of this unit. Next up, I want to have a look at the physical condition of this unit after being mounted in the engine bay and exposed to all of those elements. As detailed in my previous episode, I've wrapped the unit in this heat shield material in an attempt to reduce any chance of heat damage. The shielding has lasted fairly well, granted some of the corners and exposed edges have come loose. Unwrapping the heat shield and we can get a look at the battery itself. So after about 30 minutes of peeling, scrubbing and cleaning this battery up, we finally have what it looks like in a stock battery again. Now, apart from the scratches and the scuff marks that I've put on the plastic by taking that heat shield off, the battery is fairly good condition, but there are a couple of points to note. So I'll start off with the good things. Firstly, the plastic casing itself appears to be in good condition. There aren't any signs of plastic cracks or any fatigue on either lower parts or the orange top caps. That's one good thing. Second positive point is the terminals are very solid. They haven't moved and nor have the threads stripped, so still in very good condition. Now there's a couple of negative points that I have determined or observed once taking this battery out, and the first major one is warping of the back plastic housing just here. Now I'm confident in saying that the warping is a result of over tightening of the bracket holding the battery into place in the engine bay, and there's two reasons I say that. The first one being the warp on the back here is exactly where that engine bay bracket tightens down onto the back of the battery and was where it was placed when I took the battery out this morning. The second reason is when I push on the plastic casing on the back here, you can see the plastic bends in, which indicates there's nothing firm behind the casing here, which means nothing's moved around. There aren't any cells in there expanding within the battery unit itself. What is disappointing is I'm not exactly sure when this has occurred. The battery has been taken in and out by several shops in the last 6 months for various work on the vehicle. And what it may have done is compromise the weather seal on this top cap. So I might just place a little bit of sealant in this gap here before placing it in, just to ensure that no moisture or any other element gets into the battery. Now the second point I observed as well is that heat shielding that I placed on myself. The heat shielding would probably have done a great job in protecting some of the heat from the engine bay radiating into the internals of the battery, but what I did note is there was some moisture in that inside foam, particularly at the base of the battery. So what I might do when rewrapping this battery to put back into the vehicle is leave the bottom of the battery exposed just as stock without putting any heat shielding on there. It might just stop the moisture absorbing into the foam and remaining around the battery unit. Otherwise though, I think we can say that the battery is in a fairly good and fairly operational physical condition. One other quick point I'll mention now as well is there doesn't appear to be any damage in the engine bay of the Cruiser. This battery here is a little larger than the full river AGM that was taken out, and it does sit very tight in that engine bay, but there doesn't seem to be or appear to be any damage as a result of rubbing or vibration on the parts that the battery sits up against, so that's another good point. Now before I go into detailed testing of the battery, I do need to quickly outline how I've used, tested and stored this battery in the last 6 months, and I've done it through a variety of conditions and terrains. The first test for the battery was a weekend down in Bremer Bay on WA's south coast in the middle of summer. While we were down there, we did some forward driving on the beach, and one day in particular, the ambient temperature was 44 degrees and blowing a gale. I took the Landcruiser up a hill on the sand dunes and resulted in some of the temperatures skyrocketing. We had intake temps of 46 degrees, engine temps over 100 degrees, and transmission temps over 113 degrees. One of the other vehicles overheated on the beach and went into limp mode, and we all noticed a huge increase in fuel consumption when driving home against that wind. I'm glad to say that the battery performed well and didn't seem to have an issue there. I've also taken this battery out on several small weekend family trips as well. Not necessarily a hard test for it, but there have been off-grid conditions and getting to and from via corrugated gravel roads. I've also used the battery at our local four-wheel drive park. This meaning putting the vehicle on some seriously steep angles and also again increasing those temps by working the vehicle hard at slow speeds. Now by far the biggest test I've conducted with this battery is the 3-week trip we did into the Pilbara region of Western Australia. In this 3-week period, we relied on this battery as our main source of power and not once recharged from a mains power source. We ran multiple accessories on this trip, including a fridge, a second dedicated freezer, various camera gear, drones, computers, lights, air pumps, water pumps, and power stations. My dad came along with me for the trip, and he used the Blue Eddy EB55 power station to power his CPAP machine each and every night, and that meant that every single day this battery had to pump about 50 amp hours back into that battery to charge up for the following night. In addition to this, the trip saw a variety of terrains. We had long periods of corrugations, rough, slow-going tracks, and heaps of water crossings. There is no doubt that through some of these crossings the battery would have been exposed to some moisture. We completely exhausted the battery a couple of times on the trip as well, and that required a jump start to begin the charging process from the red arc system. The Landcruiser is generally not a daily driver and sits in a sealed garage in between trips. So for about 3 months or so, this battery has been hooked up to a trickle charger and kept in a storage mode on a lithium ion profile. For the other couple of months, I've just let the battery sit there and run, and I should note that I keep the fridge in the back of my Cruiser going at all times. Sometimes a little bit too long, and there have been a couple of occasions where this battery has been run flat while it's been sitting in my garage. I think it's fair to say that this 120X lithium battery has had a rough start to life in the last 6 months, so let's see how it's held up by doing some tests. Now most of us are aware that lithium batteries are able to power a huge amount of accessories at high amperage for a period of time compared with other batteries and still maintain a very usable voltage level. The first test I want to conduct today is a peak discharge test, and this is going to result in me placing all of the accessories I possibly can on the Landcruiser circuitry through this battery to see how it performs in both how many amps it can discharge and what level that voltage remains at. Let's have a look. So in order to do this, I'm going to be running my Waco 65 litre fridge on the freezer setting, my side camp lights, my side floodlights, my underbody rock lights, my torch chargers, my Emu Wing storage box lights, 12 volt air pump, 12 volt water pump, and the biggest accessory, my 1000 watt AC inverter. In order to load up the AC inverter, I'm going to be running an AC powered drill, an orbital polisher, and 2 AC powered fans. Now for me, this is as many accessories as the Landcruiser can power, and I really don't have the capability to plug in anything more. So providing this battery can hold up to this power draw, it's going to be plenty for what I need it for. To be honest, probably a little more than I need it for. Now I should note that we're taking the vehicle out into the field to do this test, just so you can see that it's not plugged into any external input. The vehicle is going to be off and there is no solar on the roof. So we're doing this test with 100% output with 0 input. Starting off with the smaller loads, the fridge is set to freezer, and this brings the amps up to about 4.5. We then add the campside lights, consisting of 4 Lightforce Rock 9s, and a few more amps are drawn, but then we add our LED light bars and our underbody rock lights, and we see we jump up into the 15 amp range. switching on the LED light in the EMU inbox, along with the dual torch charger, and turning on the 1000 watt inverter onto standby brings a couple more amps into the mix. Turning on the 12 volt amp pump and onboard water pump pulls about 15 amps and starts to bring us up to something a little more considerable. But now for the biggest test, adding the devices to the 1000 watt inverter consisting of the AC power drill, orbital polisher, and the 2 AC fans. Bringing that 1000 watt inverter up to its maximum of 1 kilowatt, and there we have it. With all of these accessories added, we are drawing a huge 122 amp from this lithium battery throughout various circuits in the Landcruiser. This is equivalent to over 1500 watts of power, and we can still see that voltage sits in the low 12 volt range. Although much lower than we'd expect to see a lithium battery around the 90% mark, still a very usable level. I left this for a little over 3 minutes until the water tank started to dry up and did not experience or observe any issues. So in this test we observed a surge up to 129 amps before it dropped down to about 122 for the first portion. You may have noticed that the battery did drop down to about 110 amps for the second half of that test, and that's because something went wrong with the cigarette plug circuit powering the air pump, and we lost that accessory midway through the test. Just another problem for another time. So to put this into perspective, if we ran all of these accessories continuously for a period of time, we'd probably only get about 45 minutes from this unit. Well, the results speak for themselves there. Realistically, I am never going to be putting that much load through my circuits in the Landcruiser in a real world scenario, but it's good to know that if I did need to for whatever reason, that this battery would be able to hold up just fine. Next up, we're going to be conducting a capacity test, and this is probably the test that everyone is waiting for. This is going to tell us exactly how many usable amps we're going to get out of a lithium unit like this, and most of all, importantly, we're going to be able to compare this with the results from a test done 6 months ago when the battery was brand new. So if heat really does wreck these batteries, we're sure to see a very large deterioration in the usable amps, right? Let's have a look. So in order to conduct that test today, we're going to be using this device here, and this is a battery discharger amongst other things. It allows us to set a set rate of discharge for a period of time. And for the testing we're doing today and the testing we did 6 months ago, we're going to set that rate at 10 amps. It's a realistic rate, and if we're able to get the 96 amp hours quoted by iTechWorld, it should take us a little over 9.5 hours. Now I should also mention that this device here is powered by an external AC input, so the standby draw of this device is not going to take away from those results. The device shows us plenty of information starting at the top. The IS is the user set discharge rate, and as mentioned is set at 10 amp. The VOL is the voltage of the battery the device is connected to, and the green CUR is the current and displays the exact amount of amps being drawn. You will notice that this varies plus or minus about 0.002 amps through the test. The red PWR is the power and represents the discharge rate in watts. The blue RES reflects the resistance. However, we will not be needing to worry about this for today's testing. The purple ENE is the watt hour capacity of the battery, and the bottom blue CAP is the amp hour capacity. As the test progresses, we can watch the watt and amp hour capacity increase, as this is what has been drawn from the battery. Down the very bottom, we see the time elapsed in the small white text, and finally on the right hand side, we see the cutoff voltage. I've set this to 7.5 volt. Now, iTechWorld do claim the cutoff voltage is 8.5 to 9 volt. However, I've set this rate a little lower just as a fail-safe, just in case it doesn't cut out when it's supposed to. So as the first test on the brand new battery finished up, we can plot the results onto a graph to see various aspects of the discharge profile. This graph shows us the voltage on the y-axis on the left-hand side, and time measured in minutes on the x-axis along the bottom. Plotting the data from the voltage profile of this test, and we see a curve that looks like this. We note the battery remains at the high to mid 12 volt mark throughout the bulk of the test, and the lithium can hold a high voltage level while discharging, a huge advantage over an AGM battery. We also note that once the battery starts to hit that 12.2 mark, we see that drop off very quickly. And this is exactly how a lithium battery is designed to work. In the end, the lithium battery finished with a total usable amp hour capacity of 99.3 amps. Very impressive. Just to put this into perspective, I've conducted the exact same test with the Full River AGM battery that I removed from the Landcruiser. The only difference being that the cutoff voltage was set to 10.5, reflecting an empty battery in that chemistry. The discharge curve in that test is vastly different and represents a linear pattern as the voltage drops with the discharge time constantly. We also note that the test time finishes much earlier. This is because the AGM only provided us with a total of 74.4 amps. The brand new battery performed very well and lived up to those expectations and quotations from iTechWorld and the manufacturer. So let's see how it performs now, 6 months on. The test is run in the exact same fashion with the same discharge draw. Let's get started and see how we go. A little over 9 hours later and the test is finished. Let's head over to the graph and plot the results. Placing the results onto the graph and we see a very similar result to the first test on the brand new battery. The battery remains in the high 12 volts for a long period of time before dropping off quickly at the end once it hits those low 12 volts. How does this compare to the first test? Well, here we are. The blue line represents our 6-month-old battery and the green line, our brand new battery. These lines don't get much closer than this. Although the 6-month-old battery held a slightly higher voltage, the difference only represents a 0.3 volt change. Further, the other observation is that the 6-month-old battery came in to finish slightly earlier and pulled in a total of 97.2 amp hours. So overall, I'm stoked with the result. I only lost 2 amps, which represents about 2% of the capacity of this battery. However, what can be noted is that I'm still gaining much more than I ever would with the AGM counterpart. It still holds that high voltage level throughout the bulk of the test, the only difference being that it finishes 13 minutes earlier with that slightly lower capacity now. Now this brings us on to charging. Now there isn't a particular test I'm going to be doing in relation to charging because this battery can accept many different currents and speeds of which it could be charged at. But in my experience, I only use 2 methods to charge this battery up. The first method is the Redarc BC-DC 1240D battery charger located in the engine bay of the Landcruiser 200 series. This will charge the battery while we're driving along and is able to put up to 40 amps into the battery. Now realistically, I never see 40 amps. Generally it's around the 35 mark and the most I've ever seen it produce is 37. Still, this is a very impressive rate. It means we can charge this battery from empty to full in about 2 hours and 37 minutes. The second method I use to charge this battery up, and the one I'll be using after the testing, is the AC-powered Victron battery charger. This charger has a lithium-ion profile mode, and it only charges at a rate of 15 amps. So yes, it is a bit slower, and it would take about 6.5 to 7 hours to charge this battery from empty, but there's no rush while we're sitting here in our garage. We also know that the Victron battery charger has a lithium-ion storage mode, which means that it drops that current right down to a trickle to keep this lithium battery in tip-top condition for its next use. Overall, I've experienced no issues with how this battery charges, and it's never shut down or refused to take a charge in the last 6 months, whether that be from the AC power or from the Redarc in the Landcruiser. Additionally, neither of these methods seem to have negatively affected the peak discharge or capacity test. Lastly, I want to talk about some of the pros and cons that I've come across when using this lithium battery in the engine bay of my Landcruiser in the last 6 months. Now the pros are fairly obvious and I spoke about them in detail in my last video, but higher battery capacity, higher performance in terms of charge and discharge rates, and a much more usable voltage level for the bulk of a single life cycle are a few to name. In addition to that, we do have a slightly larger unit, however it comes in at a huge 20 kilos lighter than our AGM predecessor. Now moving on to some of the negatives, and there's only really 2 negatives that I've picked up on this battery over its last 6 months of use. The first one is the initial startup cost. There is no denying that these batteries are expensive. Although becoming more and more affordable through time, they still are significantly more expensive when compared with a traditional battery. This being said, if these lithium units can live up to the cycle life quoted by the manufacturers, and we do get 2 to 3 times more life out of a battery like this over an AGM, then that value for money will become apparent later on. The only other negative I've come across when using this lithium battery in my Landcruiser is the way in which it discharges and is completely exhausted. Once this battery is completely exhausted, the BMS or battery management system within the casing will shut the battery off, bringing it down to 0 volt. When you compare this with a more traditional AGM battery, when you lower that, it just continues to lower down in voltage. You can get down to 8 or 9 volt if left for long enough. Now, although in the terms of an AGM, it would cause damage, when you start your car, the battery charger or the onboard battery charger will provide a current to that auxiliary. In the case of the lithium, when it is completely exhausted, the onboard battery charger cannot recognize the battery's presence and therefore won't provide any charge to it. Now the solution is simple. All you need to do is provide a small 12-volt charge or power to this battery for the onboard battery charger to recognize its presence, and then it will begin to charge the unit. Not an overly huge problem, but just something to consider if you are planning on switching over to lithium. So overall, 6 months on from fitting my iTechWorld 120X lithium battery under bonnet in the engine bay of my Landcruiser 200 series, I can say that I have been pretty impressed with the performance. It's performed well through all the testing that I've put it through and the real world scenarios, and hasn't let me down, shut down, or caused any electrical issues. I've put this battery through a lot more than I ever would be able to with my AGM, and it's given me the confidence that I can stay at camp longer or power more power-hungry devices and appliances. In addition to that, the testing today has shown that even through the rough terrain, the corrugations, the ridiculously deep water crossings, and the hard testing that I've put it under, it's still managed to maintain that peak performance in both the discharge rates and its capacity. Now, I'm not disputing that constant and frequent exposure to heat, like in this engine bay here, is not going to affect the overall life of this unit. And I'm not doubting that if this unit was mounted on the interior inside my cruiser, we'd probably get a much longer life from it. However, what I have shown today is that the rate of deterioration isn't quite as quick as some make it out to be. Now, although the battery is still going great just now, I'm going to continue to use and abuse this battery in the engine bay as it's mounted today to see how it goes, and I'll make sure to report back, good and bad, coming up in the future. Well guys, I hope I managed to provide some useful information today, and more importantly, information that may be able to assist you in making a decision as to whether or not a lithium battery, whether it be iTechWorld or otherwise, is the right decision for your setup. Thank you very much for watching all the way to the end. We'll be sure to see you in the next episode. Cheers.